Hello everyone, welcome once again to another Python Pandas Exploratory Data Analysis series. Here we are analyzing EDA plan for the Seoul Bike Sharing Demand dataset that you can get from UCI ML. I will share the link. We will import Pandas. We will import the dataset. Now, purpose of this dataset is explained here. We will verify data quality, understand target distribution, find relationship between target and weather time features, detect outliers and unusual events, create basic derived features useful for modeling, and we will produce visual summaries. So we will import the libraries, we will set a styling, we will find or describe data, and obviously we will do some data cleaning, everything you can see here. And then we will first create a target distribution plot. Then we will create hourly rented bike count with full series. Then we will select the daily total rented bikes, where we will select from December to November. This is daily data. Next, we will depend upon hour of day, so average demand by hour of day. Then we will learn how to calculate average demand by month. This is average demand. Then we will also learn how to find out total demand by month and demand by season. So this is part one, where we have done 7 parts, and we actually have close to 16 parts in this series. So next parts will be discussed in the part two. Till then you can try this. So everything that you have seen in this part you will learn in part one. Then we will focus on second part. Hello everyone. Today we are starting EDA for a Seoul Bike Sharing Demand dataset. In this Seoul Bike Demand Sharing dataset, first thing will be to load the dataset, which we have in a CSV format, and we will simply upload it on our platform. We are using Google Colab here. So first thing is to connect to the runtime environment that we have. So now you can see it is connected to Python 3 Google Compute Engine backend. Then we will upload this file to the session storage. So here is the option to upload to session storage. And here is the CSV file. This CSV file can be downloaded from this URL. So it is getting installed. Here you can see this is the URL from where you can get this file. Dataset contains count of public bicycles rented per hour in the Seoul bike sharing system with corresponding weather data and holiday information. So subject area is business, associated task is regression. We will do exploratory analysis. I am sitting in a different environment today, so it might be a little bit noisy. Sorry for that. You can read dataset information that currently rental bikes are introduced in many urban cities for enhancement of mobility comfort. It is important to make the rental bike available and accessible to public at right time as it lessens waiting time. So this is about the data set. We will use Python to do exploratory data analysis. Once your file is loaded, copy path and say that data equal to this path. So once you have that, now we will import our libraries. So first library will be import pandas as PD, and this library is used for data processing, and data analysis will be done with the help of this library. Now we will say df is equal to pd.read underscore csv, because the file is CSV file, and here we will just say data, and encoding will be Latin one. This encoding is automatically suggested by Google Colab. We'll go with it. If you want to see top 5 rows of the data, like what it shows, you can write df.head, and now you will be able to see. So here you can see we have date, obviously date of transaction of this file, then rented bike count, how many bikes were rented, what was R, temperature at that time, humidity percentage, wind speed in meter per second, visibility, dew point, solar radiation, then rainfall in mm. We also have information of snowfall in centimeter, and we have season, whether it was winter or any other season, whether it was holiday, yes or no, and was it a functioning day, yes or no. So this is the information. Now once we have the data, now we will start data analysis. Now here I have listed EDA purpose, like what we want to learn. Verify data quality, that is types, duplicates, and missing values. Understand target distribution. So finding relationship between target and weather time features to find out correlation trends, detect outlier and unusual events, what is heavy rain or snow. Then we can create basic derived feature which is useful for modeling. That is date, time index, cylindrical, hour, encoding, month, day of week, etc. Or produce visual summaries like time series plot, heat map, box plot. We'll see whatever is required that informs feature engineering or models. So we already imported Pandas. Now we will import NumPy, Matplotlib, and Seaborn as SNS, and we will run this. So this will give us the necessary libraries. And when we are doing exploratory data analysis, we can also set use style. So we are importing matplotlib.pyplot as PLT. We are importing Seaborn as SNS for plotting graphs and visualizations. So plt.style.use Seaborn is optional. You can remove if you want to use default matplotlib style. And Matplotlib inline will make sure all the graphs are plotted inline. That means in this Jupyter notebook itself. So here, let me use a different one. So basically, in newer Matplotlib, it is deprecated. So we can include Seaborn V08, Seaborn V08 dark grid, white grid, etc. So that we can easily use them. Let's try this. And now you can see this is successfully imported. Next, we will do quick data inspection. For quick data inspection, we run commands like df.shape, df.import, and df.describe. Shape basically gives a tuple and tells us how many rows and columns do we have. Then df.info will give you information about what data types do these columns have and how many missing or non-missing values we have. So you can see in date, rented by car, hour, etc. All of them have all values because we have total of 8,760 entries and all of them have these many non-null values. Finally, we can write this df.describe.t. So it is a numerical summary showing mean, standard deviation, minimum, maximum, and quartiles, so which we can see here. So it will take all the numerical columns. So rented by count, hour, temperature, humidity, etc. are all numerical columns that are either given as int or float here. Object values are basically string values or categorical values that we have. And from here you can see how many different count of values do they have. Rented by count 704 is mean, standard deviation, minimum, maximum. So you can see when there is a big difference between different values, so you will get a higher value of standard deviation. So from here you can get that. In wind speed, standard deviation is very low, so you will be able to easily understand that. Next, we will standardize column names. So standardized column names means make subsequent code robust. So for that, what we have to do is we will clean column name to snake case and lowercase. So df.columns equal to, we will select the columns and from their string we will strip any spaces. Then we will replace with underscore if there is a space, percentage, or any kind of special character. We will set regex is equal to true. Then we will strip underscore and we will make it to lowercase. And after this, if you will print the column names, then you will be able to see the column names are now given like this: date, rented by count, hour, temperature, humidity, etc. So you will be able to see the column names more properly. Next step is we will create a proper date time index. Having a date time index will help us in creating time series charts more efficiently. So we will create date time from date plus hour column. UCI has separate date and hour column. You can ensure data column format is YYMMTD format. If not, you can adjust the format accordingly. So we will write df.datetime equal to, so we have imported pandas as pd.toDateTime. Then we will write df date as type string, plus we will add a space, plus r as type string, plus we will add these time parameters 0000. Then we will set index as this date time column, and then we will sort the index. So optionally you can drop the original date column also. And when you will run this, let's see what issues we have and we will resolve it. And this is because of different date format that we have in the dataset. As I said, if it is given like this, so I have a separate solution here, and that separate solution is to use pd.toDateTime to convert the date column day first equal to true, and then we will use df equal to date plus pd.time delta. So we will convert this to time delta, and we will select dfr where unit equal to r, and then we will set the index and sort it. Let's try. So this code will set time index. So we will, when we will write df.head, so you will be able to see now date time is appearing like this. Okay, and after it is appearing like this, and you also have the regular date, and now this particular column is set as date. Optionally we can delete this also because it will not be needed anymore. Now part 4 is sanity checks, that is missing values, duplicates, and types. So obviously we have seen that we don't have missing values, but we have to check for duplicates and types. So here we have data quality checks, like you can print missing values per column. So df.isNA.sum will give you that. Then you can print total duplicates, df.duplicated.sum. So df.isNA finds if the value is not a valid number or not available. Df.duplicated, this particular method checks is that particular column or how many values are duplicated, and then its sum will give you that many values. Then we can check minimum maximum of R column. It should be 0 to 23. So we can print R dot aggregate minimum, maximum, and n unique. So this will give us that none of them have missing values. Total duplicates is 0, minimum is 0, maximum is 23, and unique is 24. So it gives us that data is properly formatted. It has no missing values, and even the R values are also properly given. Next, we will have our quick target, that is rented by count. So for quick target rented by count, let's do the analysis now. So for target distribution, we will write target is rented by count because that is the name of column that we are marking as target value. df.target.histogram, we are now creating a histogram of this particular variable. As a title, we will write distribution of rented bike count. As a X label, we will write rented bike count, and as a Y label, we will write frequency. And later we will print the summary stats of this. First, we will run this, and you can see once we set the style of Seaborn, we now have the distribution of rented bike count. So this distribution diagram we can also open in new page. You can see from 0 to 3500 we have rented bike count range, and most of the range are between 0 to 450, we can say. Here the frequency is close to 1000, and rented bike count when it is around 3500 on a particular day or more than 2500, the probability is very low. And you can see rented bike count as it is increasing from 500 to 2000, it is slowly decreasing, and it is decreasing from around 350 to somewhere around 50 or 60. So this is how this the rented bike or our target column is distributed. Then we can also write the target summary. So target summary gives us this information that minimum value is 0, maximum value is 3556, and what is the first quartile, second quartile, third quartile, you can see, which will help you in understanding how the data is distributed. Optionally, you can also create a box plot from this variable to understand this visually. Next, we will have time series plots and seasonability. For time series plots and seasonability, so that's why we have done set index of time. So in part 6a, we will plot full time series sample. Since 8760 points is fine, we will use a figure size around 14,4. We'll take our target and we will plot. Because index is already set, the title will be hourly rented bike count, that will be full series, and Y label will be count. Once you will run this, so you will be able to see hourly rented bike count, and we will have a time series. So starting from December 2017, then you can see January and how this count varies. So this will help you in understanding depending upon, and you will be able to understand monthly trend of how many bike rents are there, how many bikes are rented monthly, and we can see that it starts rising from March and goes up to its peak in July and goes down. Then again it goes up in around September, October month. So this is how you can see hourly rented bike count, and this is a full series. Next, we will find out daily aggregated trend. So for daily aggregated trend, we will create a variable called daily, where we are going to take the target value and we will resample it as D. This is daily. Then we will use sum, and then we will create another figure of the same size, and then we will set daily dot plot. So dot plot basically means a line chart, and once you will run this, you will be able to see daily value. So now you can see daily total rented bikes, how is it changing, and here you can see count, it starts from 0 and goes up to 35,000 here. So this is daily total rented bikes, and you can see months where it was at its peak between June and July, and it was also very high between September and October month. So this is daily aggregated trend. Next, we will have hours of day, day of week, and months effect. So it is important because when we are analyzing how many bikes will be rented, so having it by hours of day, day of week, monthly is also important. Here we have taken the complete time. So now let's start that. So now you can see we have R. So we will select dfr as type integer to ensure it's numeric. We will take month, df dot index of that month. Then we will take day of week. We will have df dot index day of week. Monday will become 0. Then we will take hourly mean. So we will group by R and select target and find its mean. Then we will set the figure size at 8, 4 and hourly mean plot, which will give us average demand by hour of day. So we'll first plot one of them. So you can see at 18th hour, maybe office closes or people are going for biking. So whatever is the reason, this is one peak hour and this is also a peak hour early 8 a.m. So depending upon that particular city, depending upon how that area behaves, you can select this and in a similar way you can create average demand by uh, you know month and day of week. So we can also do box plot by season if season column exists. So if seasons in DF column, we will again create 8, 4 figure. In box plot, we will take seasons on x-axis. Y will be our target because we are analyzing this. And in data, we will now reset the index. So, and title will be demand by season. So once you do that, we will be able to see demand by season. So you can see winter season, demand is very low in a spring season and it is highest in summer season. And when the demand starts from 500 mark and goes up to 1500. Obviously, we have outliers in every season, but you can see in most of the cases. Here you can see mean is slightly on the upper side in autumn season. In summer season, mean is slightly lower below the mean value. And here in spring also you can see. So this will give you an idea of in which season demand is more. Now, why have we done that? It is important that in your report you write this thing also. It confirms commuter peaks, that is morning and evening, weekend versus weekday patterns, seasonal differences, everything can be understood. For example, let's take like we have done hourly day. So we will try to duplicate this. Let's add a code here. Here you can see hourly mean. So let's say monthly mean. So we will just replace monthly mean and here we will write month mean demand or monthly mean demand. Now monthly mean we will df dot group by r. Here like we have given r here, here we will write month. So we will write month here and set target as mean. Everything will be okay. We'll just replace this with month. So now you can see average by month and you can see from 0 to 23 it shows. So it was showing 24 but we have to fix that because we cannot show 24 months. So month will be df dot index month 1 equal to January, 12 is equal to December. Monthly mean will be df by dot group by month target mean. Then we will create monthly mean dot plot. So first you have to create monthly mean. Then you will group by and group by month and then select the target column and find its mean. Then monthly mean dot plot we will use kind equal to bar and then we will set the titles accordingly. This shows that in the 6th month, that is June and July and you can say May, June, July are the months where average demand is high. If you want to find out total demand, so instead of mean, you can also use sum. So I will show another code here and here we will select monthly total. So we can run, and this is monthly total, and this also shows in total also monthly demand in the month of June, July, and May are more. So these two plots, you can compare that how monthly demand varies, average monthly demand varies, and total monthly demand varies.